Connectionist. The term connectionist actually means different things to different researchers, and so we begin with connectionist model definition. A connectionist model is a network of units that connect to one another through links or connections that can vary in strength. Moreover, the kinds of connectionist model that have been applied to aphasia exhibit considerable variety. To illustrate this variety, we have chosen a model which we will describe in sufficient detail to give a feel for how they explain language impairments. It is the interactive two-step model of word production. Interactive two-step model of lexical retrieval in aphasia speaker. The interactive two-step model is a word of single-word production derived from a general theory of production in which linguistic units are retrieved by spreading activation in a layered network. The picture illustrates the three layers that are implemented in the model, such as semantic input layer, a word layer, and a phonological output layer. The units in the network create localist representations, that is, units correspond directly to particular linguistic units such as semantic features, words, and position, specific phonemes, respectively. The connection in the interactive two-step model are all excitatory and run between adjacent layers. So the semantic features of, say, cat have positive weight to the cat word unit, which in turn is positively connected to its phonemes, uk, a, and ut. The connections do not just run in top-down or meaning to sound direction. There are also excitatory bottom-up connections from each word's phonemes to that word and from the word to its semantic features. The existence of both top-down and bottom-up connections make the retrieval process interactive. Lexical retrieval involves two steps. They are word retrieval and phonological retrieval. Okay, the first one is word retrieval. Word retrieval begins with a jolt of activation to the semantic features of the target word. For example, cat. The activation then spread throughout the network down to word and phoneme units and upward as well. After a period of time, the most active word unit selected, thus completing the word retrieval step. And then the second one is the phonological retrieval step, begin with a jolt of activation to the selected word's lexical unit. Again, activation spread through the network both upward to semantics and downward to the phonemes. The phonological retrieval step is concluded by the selection of the most active phonemes units. The selection of phonemes is analogous to the prior selection of the most active word unit that concluded the word retrieval step. If the selected phonemes units do not correspond to that selected word unit, the result is a phonological error. Phonological errors can be non-word, for example, keg for cat. Keg has no meaning, or they could be word, thus creating formal error, for example, mat for cat. Notice that formal error can occur at either the word retrieval step or the phonological retrieval step. Notice as well that a phonological error can be made on top of the lexical error. If dog was selected instead of cat at the word retrieval step, poor phonological encoding of dog may compound the error into something like mug. These kinds of error are extremely rare in normal speakers, but are not uncommon in aphasic speech. The model explains such error through its assumption of two retrieval steps. And in the next one, continue to the testing predictions from the model. The interactive two-step model attributes aphasic error to low connection strength in the lexical network that store words, their meaning, and their sounds. The interactive two-step model is simple in another way. It assumes that all connections of particular type have the same weight. Clearly, this is wrong. The strength of connections should reflect differences in an individual's experiences with words. The remaining two models presented in this chapter address effects of experience because they include a learning component. In these models, the waves are set by exposing the network to training trials that stimulate linguistic experience. And then the next is about a parallel distributed processing model of naming errors in optic aphasia. The parallel distributed processing or PDP model of Bolt and Selle's 1993 is designed to mimic the impairment of optic aphasia. Patients with this disorder typically make errors when naming visually presented objects. Their mistakes are often semantically related to the target, or responses related to the previous target or perception. However, they are rarely impaired at naming objects presented in order to modalities and on tasks of visual object recognition. And then in training, setting the model's long-term connection wave. The model's architecture specifies the units and the potential connections between them, but the connection wave must be learned. Moreover, each connection is associated with a long-term wave, or like a wave used in the interactive two-step word, as well as short-term wave that reflects the model's recent experience, to induce respective behavior when the model is tested. The activation that is sent from one unit to another is a function of both the long-term and short-term waves on the connection between them. And then the next is about comparing model behavior with patient performance. Holt and Sells did not calculate numerical measures of the model fit to empirical data, but instead compared the overall pattern of error produced by the model with that of a peak aphasic patient. If the model mimicked the patient data, the author's goal was to explain why the model behaved as it did, and apply this explanation to the defects in optic aphasia. The model's rates of making different error types were compared to a chance rate, or a random pairing of errors with the other objects, to assess the influence of visual and semantic similarity and perseverations in the model. And then the next is about strength and limitation. The first is strength. The optic aphasia model successfully stimulates the errors made by optic aphasias in visual object naming. It does this by storing visual and semantic representation of objects in a distributed manner and allowing the mapping between these representations to develop in a way that minimizes error, rather than imposing mapping according to a particular theory. The model's use of separate direct and indirect pathway leads to the development of attractors that move representation away from visual similarities and towards semantic similarity. And how about limitation? The limitation, although the optic aphasia model is more realistic than the interactive two-step model in its incorporation of learning, the tests of its empirical validity are more limited. Holt and Sellis compared the model's performance to view patients, and their comparison are more qualitative than quantitative. Perhaps more importantly, the model's predictions were not systematically tested. Also, this model only stimulates one kind of aphasia, and so it is only to conjunction with other stimulation that it moves towards the holy grail of developing a single computation framework that can account for variety of aphasic data. And then the last one is about aphasic lexical access in sentence production. Compared to the two previous models, our last model, the Divisions of Labor or DOL model according to Belden and Dell 2003, is quite modest in both its aims and its accomplishment, and it is noteworthy as one of the few connectionist models of aphasia that actually attempt to stimulate the production of sentences as opposed to single word. In conclusion, the connectionist approaches share what can be called a cooperative view of language processing, although the models have spared network level that correspond to distinct representational types, such as phonology or semantics. The levels work together to explain empirical phenomena. Connectionist models also allow for multiple levels to affect processing through learning. For example, the learned weight from syntactic states in the Dole model depend on the semantic complexity of verbs, and the weight in the opaque Aphasia models reflects both semantic and visual similarity. The cooperative view of language processing has much of our research on communication disorders. The diversity of symptoms and syndromes, the multi-level nature of errors, and the often implementable relation between behavioral and relation logic argue for models that respect the interactions among processing components. Despite lacking our present-day computational tools, Michelheim no doubt recognized this when he made the first diagrammatic model of aphasia in 1885. Thank you very much.